Welcome back to the Grounding and Bounding Masterclass series. This is episode 3, and today we're breaking down the difference between a ground rod and a ground plate, and when each one is used under the OESC 2024. This is the one area apprentices mix up all the time, and even licensed electricians sometimes install the wrong grounding electrode or size the conductor wrong. By the end of this video, you'll know exactly which one you should be using, how to install it, and the code rule behind it. First, let's clear the biggest confusion of the grounding electrode system. Rod plates, concrete encased, whatever does not trip breakers. It is not a fault clearing path. It is bounded. It is not bounded. Grounding electrodes do 3 things: stabilize voltage, reduce lighting impact, provide an earth reference for the service. That's it. Breakers trip because of bonding, not the earth. Section 2, ground rods. Let's start with the ground rod, probably the most common electrode people think of. In Canada, OESC 2024, minimum 10-foot rod must be copper clad or stainless steel. Minimum diameter 12.7 millimeters, ½ inch. Must be driven full length into the earth. Cannot be bent or angled. Must be distributed style. Must be in undisturbed soil. If the rod does not achieve 25 ohm, then OESC allows a second rod, a ground plate, or an acceptable alternative electrode. Number 6, copper minimum for most residential, 100 amps/200 amps. Number 4 or larger for 400 amp service, dependent on service size. OESC 2024 Table 16. Your rod must be tested or paired with another electrode. Now let's talk about the ground plate, the one most people forget about. In Ontario and many parts of Canada, the ground plate is extremely common because our soil is rocky, frozen, or too hard to drive rods. Ground plate requirements, OESC 2024, must be at least 0.2 meters square surface area. Minimum 6 millimeters thick copper or acceptable steels alloy. Buried at least 600 mils, 24 inches underground. Must have direct contact with earth. Must be installed horizontally for maximum contact. Clamp must be accessible. Plates are expensive but very effective where ground rods fail. GC size, same rules based on service size. For 400 amps, typical 4-aught copper minimum must be continuous or irreversible splice. Section 4, rod versus plates. When to use each. So which one do you choose? Use a ground rod when soil is soft. You can achieve full depth. You can get 25 ohms or install 2 rods. Rural or open ground space available. Use a ground plate when soil is rocky. Rod cannot be driven. Space is limited. You want a guaranteed grounding electrode. Cold climates where frost line is deep. In Ontario, we use a ton of ground plates because of soil conditions. Contractors use rods where soil conditions allowed. Here are the OESC 2024 sections for this episode. Rule 10-700 states, grounding electrodes permitted. Rule 10-702, grounding electrodes installation. Rule 10-806, grounding electrodes conductor sizing. Table 16, minimum copper and aluminum conductor sizes. Rule 10-802, rods and plates characteristics. Rule 10-902, connection to ground rods and plates. Keep these in your code book. You will use them every day in the field. Here are the OESC 2024 sections for this episode. Rule 10-700 states, grounding electrodes permitted. Rule 10-702, grounding electrodes installation. Rule 10-806, grounding electrodes conductor sizing. Table 16, minimum copper and aluminum conductor sizes. Rule 10-802, rods and plates characteristics. Rule 10-902, connection to ground rods and plates. Keep these in your code book. You will use them every day in the field. So that's your full breakdown of episode 3. Ground rod versus ground plates on the OESC 2024. Understanding the difference helps you choose the right electrode based on soil conditions, code requirements, and also service size. If you followed this masterclass series, Episode 4 is coming next. We're going into neutral isolation and how to wire sub-panels correctly. Drop your questions below. I respond. So I say I want to bend at 12. Mark 12 inches. And I'm going to do the take up. For 3/4. So this is going to be a 90, okay? So I have 2 marks here. One there, 1 mark here, 1 mark here. This is where I'm going to bend. I'm going to place it on the arrow, okay? See, in it, don't need a measuring tape, and that's all you do is now we're going to get into the 4-bend saddle, which everyone has issues with. So I'm going to do a 4-bend saddle, and I'm going to cut some pipe. Normally it's very easy when you don't use the full length of the pipe. So I'm going to cut off. I'm actually going to use this, so I'm going to leave this bend here. Matter of fact, I'm going to do the 4-bend saddle with the full length. So to set up a 4-bend saddle, we need the middle. That's my middle mark there. And then I'm going to come off of this mark. I'm going to go about 6 inches. So whatever I do on one side, I have to do on the other side. So 6 inches. So 6 inches. As you can see, normally when I do that, it's very important. I can see my mark all the way around, and I don't dogleg my bend. So let's get into the 4-bend saddle. First mark is at the start. So I'm just winging this, guys. I haven't done a 4-bend saddle in a while. So So again, this is the conduit that I'm going to be working with today. And as you can see here, I've got my core line cutters, I've got my tape. Core line cutters, I normally use them to cut my PVC pipe ends. And as you can see with the pipe here, I've got basically tape at the end here in order to stop the gravel from going in. And this, what I'm going to be doing is running this PVC conduit to the other end of the wall, and I'm basically going to snip this off like this with my core line cutters. And I'm also going to place some tape at the end of the pipe, that way it doesn't get gravel inside of it. This acts like a coupling, same thing. This is how they come, 10 length. You'll get the, some guys call it a bellend, but this is what you call a 1/2 inch coupling also. Normally what I do at the end, I place around my glue around here. That way it's firm, secure. Twist at the end to make sure it's not moving. That piece is done. And then we're going to move on to the other piece. Now I need my 1/2 inch coupling at the other end. These screws, and you basically take this out. I'm just twisting these so I know these are the neutrals that I need. And also, this panel is not live. It's actually against the law to work live without the proper suits, which means proper headgear, proper face covering, proper clothes. As you can see, I always wear cotton. Cotton basically will take longer to burn if you're going to have a shock or an explosion, rather than using the silky material, which will basically melt in seconds. So I always use cotton of everything. So as you can see, this one side is finished. This one wire, actually this is short. It's going to go onto the neutral bar also. These wires here will all get a special breaker, so that's the reason why I'm not tying these wires onto the neutral bar. These wires on this side, they're not labeled, so I will have to trace them out.
footage of hydro coming in to bringing the power into the home. So we'll go over to the other side where they have started to suck this machine that they will use to basically suck the dirt out. Okay, so that's basically what you're going to be using to suck the dirt out of the floor to basically get my power over. As you can see, it's a machine that they will make the holes to get across somehow. I have seen it before, but I've worked beside them years ago when they do this type of stuff. So that machine is basically, I don't remember the name of the machine, but it's a machine that you can basically suck the dirt out of the ground, and everything's basically done neatly. And this other machine that I showed you this morning here is going to be a machine that they will drill across to go. I'm going to flip the camera just slightly over because I don't want to have the other worker on the video. So basically that's what they're using. And he's going to try to make his way all the way over to the other side. So basically what I'm doing today is I'm just going to be hanging out as you come in. You can also hit the like, share, and subscribe button. Stay up to date to my recent content. So right now that's hydro, basically digging. That's the machine that they're using. The reason why I have the camera like this is I'm trying not to get them on the video because I don't know if they want to be on the video. So from time to time I will just tilt my video. So please hit the like button as you come in. You can also leave a comment. You can also subscribe to the channel. Stay up to date to the latest content on electrical, the hazardness of electrical, the danger behind electrical, and the knowledge that you can gain of how we go about doing our work, our daily job.
Please don't forget to like, share, and subscribe to this channel. And don't forget also to click on the subscription.
So basically that's the hydro crew guys working.